but I don't want to do that compulsory because in the chapel they are going to check your ID badge. The committee does not want your last name because they don't want your identity to be in, and they don't want anything that's identifiable. They don't want to know that which place I am. It's completely anonymous, but in my record, I will be the same person teaching every 5 years. So I will be growing old. And once again, it's not about your behavior. It's about if I have the ability to deliver the content. Like when I just fresh out of college, they know I can teach, but as I grow older, they may not know. So that's the thing. Okay, so I need you to go to nearpod.com and then type in the code. So you can also type in the code to this link. So it's in Unit 5 and it's supposed to be last Friday. So there's a indirect link. So if you can kindly go to the link, that would be helpful for me. If you can kindly go to the link. Thank you and enjoy the session. And I also asked him not to take your face, not to put the camera on your face because no one cares about your face. No, it's okay. I specifically asked him. They really don't care about your face. And they really don't care. They really don't care. They just want to know if I can teach math. So.
She doesn't have her device.
Okay.
She's the best.
Are you ready? Okay, so let's start. So we want to talk about indirect proof today. And then so by looking at this picture, what do you think we are going to talk about today?
Oh,
Red? Okay.
The side.
The side, okay. And how about this picture? So by looking at this picture, what do you think what we are going to talk about?
The congruent side.
The congruent side?
The prices.
The prices.
Yeah.
You're so smart. That makes sense. That's the prices. Yes. So what are we going to learn today? How smart? This is a collaboration board. So you can type an image. So you can go here and you can search for an image. Like, yes, what are we going to talk about today? For example, somebody said price. And then you will see these pictures. And then you can share it with the class. So share with us, like, what do you think we are going to talk about today? Oops. What happened to your side? Okay, so try to type and search an image. So type it here and click on the image, right? And you can start searching. Like, for example, bag, and then search. And then you can choose an image to share. So let's use a couple of times and guess. Oh, yeah, you can use cards. I'm so used to example.
Oh, it's fun. It's fun. But what do we have to do now?
So get the picture. And then guess what I'm going to talk about today. You can just search. Oh, so you can just search.
Wow, smart.
So we have a couple of examples now. Some pictures of the things so people think about. We're talking about reflections and money. Okay, these are really good. And then guys, very cute. Going to hide. Okay. So here's a picture, and that's a story we want to talk about. So there are two girls. So Amy and Joy, and they went shopping. And then, so they went shopping. And together, they are going to spend some money. Okay. And then, so Amy and Joy, they went out to shopping. And then together, they spent $100. Okay. So, do you agree that at least one of them spent at least $50? Do you agree or disagree? Can you talk to your friends and see if you agree or disagree? Like, do you agree that at least one of them spent at least $50? Like, what do you think? If Annie and Joy, they went shopping, and do you agree that at least one of them that spent at least $50? Okay, I'm going to call up some of the names. Zoe, what do you think? Do you think at least one of them spent $50?
What? Sorry?
If Amy and Joy.
Yes.
Why?
Could
No
at least
reason.
one of them spend at least 50.
Yeah, why?
Why? Because
Spend more than 100.
what do you agree that? Yeah, because they need to, like, the two other persons, like, their money, like, added really 100.
Okay.
Probably one person. At least, yeah, I think.
Yeah, I think you're
I
right.
know the answer.
Yes, what do you think? Why?
And what I think about their pocket.
Okay.
Their pocket and they have some.
Excellent. So they have the same. Sylvia, what do you think?
Yes.
Why? So cute. Why?
Because
Because no is
Because at least they need to spend
At least they didn't spend $50.
so like they multiply
In
at least their total cost it will be 100.
Okay, excellent. So the total should be 100. That's very good. So Sylvia, you think the same thing? Yes. Let me ask somebody. Henry,
有默契有默契。
what do you think? If two girls, Joy and Amy, they together they spend more than 100, so at least one of them spend at least 50. Yes or no?
Yeah.
Why?
因为他们除以2是50啊，他除以2是50加起来100，他不管哪边多，另外一边就会少，不管谁少，另外一边就会多。
Okay. So then how do we prove this? So we want to learn how to prove indirectly. Okay. So this is a math questions that you will see. So Amy and Joy, they went shopping together. They spent more than $100. So use an indirect proof to show that at least one of them spent at least 50. Okay. So let's try to review. Okay, so a couple of review here. House, if the statement is Los Angeles is in California, what is the negation? Yeah, what is the negation? If Los Angeles is in California, that's a statement. What is the negation? Okay. Miu, what do you think? What is the negation of Los Angeles is in California? Yes, Los Angeles. What is the negation of? Yes, so the statement is Los Angeles is in California, and then the negation is Los Angeles is not in California. Okay, the second thing is the conditional statement. So we have if, then, for. So if today is Monday, then we have assembly. That's an if then. That's a conditional statement. If n is divisible by 10, then n is divisible by 5. Okay? If a quadrilateral is a square, then it has 4 congruent sides. Okay, so indirect proof. So how do we start? So we receive a question in the lab. Amy and Joy went shopping together. They spent more than 100. And use an indirect proof to show that at least one of them spent at least 50. So transform into a proof given that Amy and Joy spent more than $100. Prove that at least one of them spent at least 50. So here's your chance. I know you are not going to know it because I haven't taught it. But let's try to formulate this into math. If Amy is y and Joy is x, Amy is x and Joy is y, then what is the algebraic expression? Try to write the mathematical equations. If Amy is x and Joy is y, yes.
Can I use the restaurant?
Yes. If Amy is x and Joy is y, then how do we try to use mathematics expressions to formulate the question?
Miss Joanne,
Yes, how are you?
can you turn off the AC, please?
Yes, no problem.
Thank you.
How I formulate this into mathematical equations. That was spend more than, together they spend more than $100. How do you use math language?
X plus Y.
More than.
X plus Y 大于
Write it down.
现在算不喜欢了。
Yes, Allah! Then how about proof? How about proof?
Okay.
At least one of them is, how about proof?
At least one of them.
At least one of them. At least one of them. How about at least one of them? Thank you, thank you. Yes, at least one of them. Okay, let's check out some of your classmates' answers. So one of your classmates said x plus y larger than or equals to 100. Okay, so what do you think about this? You have more than 100. And at least one of them, oh, you studied, thank you. At least one of them is different. And how about the proof? So you formulate the given, and how about the proof? Excellent. Okay, so let's talk about this. Do you see this? Amy and Joy spend more than 100. So if it's more than, then you don't have the equal sign. So it's just larger. And then second, you have at least. So x is larger than or equals to 50, and y should also be larger than or equals to 50. Okay, so here's a mathematical equation. So given x plus y larger than 100. Okay, so Amy, at least we have to prove that x is larger than or equals to 50, or y is larger than or equals to 50. Okay, then try to write this one into if-then form. How do we write it into if-then form? If we want to formulate the given and the proof into if-then form, like how do you formulate it? You can type. How do you formulate that into if-then form? If something and then something. Yes, yes, please. If something and then something. Thank you so much. Yes. Okay, so we have somebody share here. So what do you think about this? If okay, can you help me submit it? So then somebody has submitted the answer. So the answer is here. So if x plus 1 is larger than 100, then x is larger than 50, and we also have or y is larger than or equals to 50. So if x plus y is larger than 100, then x is larger than or equals to 50, or y is larger than or equals to 50. Okay, then how do we write negation of the proof? How do we negate the proof? Try to negate the proof. Try to negate the proof. How would you negate the proof? If I want to negate the proof, how would you negate the proof? If I want to negate the proof.
What's negate?
Negate means the other side. Like I live in Taipei, the negation is
Taipei is where I live. I live in Taiwan.
Negation of this one. Okay, so we get some negation here. So if x is okay, then okay. This is nice, okay. So when you negate the proof, you can actually see the negation is x is smaller than 50 and y is smaller than 50 because your statement is x is larger than or equals to 50 or y is larger than or equals to 50. And when you negate it, is x is smaller than 50 and y is smaller than 50. Okay, so next one. Try to plug the assumption into the given. If x is smaller than 50 and y is smaller than 50, then how do we prove that the given is not true? So how do we prove that we'll reach a prediction? So try to plug these guys, the range of x and the range of y, into the given. So try to plug range of x and y. So now you have x and y. So try to use x plus y and see what conclusion you will get.
As concludes what?
Yes, if you have x and y, then yes, write it down. If you plug it in, then what do you get? Because now you have x is smaller than 50 and y is smaller than 50. Then what's x plus y?
Then x plus y must
It's actually smaller than it's 100. Because this is 50. Yes, thank you. Okay, so you can see if x is smaller than 50 and y is smaller than 50, then together, when you x plus y smaller than 50 and y smaller than 50, then together is smaller than 100. Okay, so now you can see the conclusion part. X plus y is smaller than 100. Okay, and x plus y is smaller than 100. Do you see your given? So you compare the conclusion we reach and the given. So what do you see in here? So following the negation, we reach the conclusion that x plus y actually is smaller than 100. But the given is x plus y larger than 100. So what do you see in the difference? So as we prove, right, x plus y should be smaller than 100. But how about the given? The given is x plus y larger than 100. What do you see in here?
x 大于等于50，那 y 就是不大于50。所以如果 y 大于等于50，那 x 就不可以等于50，那就一定要大于50，不然你的结果就是100，就会大于100。
Yes, exactly. Okay.
是吗？答对吗？
Yes.
哎，完成。
Yes.
又猜了。
Mia, what do you see in the conclusion we reach and the given in the proof? Can you say it again? I'm sorry.
If your x and y is less than 50, then their sum will not be greater than 100.
Yes.
But if your x and y are larger than 50, then their sum is greater than 100.
Exactly. So exactly. Okay. So then by doing this, you know they are contradict. So, okay, so because we arrive at contradiction when we assume the negation of the conclusion is true, so the conditional statement cannot be false and it must be true. So because class, we use the negation and we plug into the question and we prove that we reach a contradiction. So the conclusion that we get from the proof, we reach a contradiction. When we assume the negation of the conclusion is true, so the conditional statement cannot be false and it must be true. So by doing this, we prove that the given is true. Okay, so this is indirect proof. So this is a review of the step of indirect proof. So there's an if-then form, and then we assume the negation of the conclusion is true. Then we plug in the assumption using given, and then we compare the result of the given. Yes, thank you. Okay, so then now what we are going to do is I have one more examples about the algebraic indirect proof. The question is here. The question is given that negative 2x plus 1 is larger than 3, then we have to prove that x is smaller than negative 1. Okay, so I'm going to give you the handout for the indirect proof. And then today we need to finish a worksheet about indirect proof. So there are 4 questions. They are real-life example, algebraic expression, geometric expression, and a challenge question. Okay, so here are the handout for one more example, the algebraic proof. Thank you. So try to read through it.
So we're working on it.
We have a worksheet that we need to write. Okay, I'll just give that to you.